Hello and welcome back. In this lecture I want to start talking about string functions. I mentioned earlier that strings, character arrays, are not a variable type, a data type in C. So you can't use any of the operators, but you're still going to need to be able to do a lot of things on strings. You're going to be able to manipulate them. You're going to want to get the length. You want to compare them, all sorts of things, probably convert them. So luckily, the standard library comes with a bunch of functions that you can use to perform these type of operations. I'm going to first start talking about some of the most common ones, and then we'll move into some more specific ones in other lectures. So we already know that a character string is a char array terminated by a null character. Character strings are commonly used in C programs. C luckily provides many functions specifically designed to work with strings. The ones that we're going to discuss are the most common ones that you'll use. First, getting the length of a string using the stir length function. Copying one character string to another. Remember I told you earlier that you can't use the assignment operator to assign a string. So what you do is you use stir copy or stern copy. Also combining two character strings together, concatenation. There's a stir cat and a stern cat. And determining if two character strings are equal. Again, the equals equals operator is not going to work for comparing strings because they are arrays. So if you want to compare strings, you have to use special functions provided by the C library, stir compare and stern compare. First, let's talk about the length. All of these functions are defined in the string.h header file, so you have to include that when you call or invoke one of these functions. Getting the length of a string. Stir length is a function that finds the length of the string. It's pretty straightforward. It's returned as a size t variable. You can pretty much use the size t variable interchangeably with an int. But first you'll have to include that string header file if you want to use stir length. And this is how you use it. You basically create a string literal inside double quotes and you assign it to a character array. You don't specify the size of the character array. The compiler will do that for you and it will add the null terminator. Once you have my string defined and with a string constant, you can then call stir length and just pass in that character. Pretty nice. It's one of the most often used ones because you often want to get this length of a string when you do validation checks or anything really. If you want to make sure there's no buffer overflows, you can do that as well. This function does change the string, so the function header does not use constant in declaring the formal parameter string. If you were to go and look at string.h inside user include in your directory, you would see that it's not defined as a constant. Copying strings. Copying strings are either modifying an existing string, modifying an existing character array that has some data in it, or if it doesn't have anything in it, you want to put something in there. Since you cannot assign arrays in C, you cannot assign strings either. I mentioned this earlier. Declaring a character array and then using the equals assignment operator does not work. So what you have to do is you have to use the stir copy function to copy a string to an existing string. It's the equivalent of an operator for strings, assignment operator. If we declare two character arrays, source and destination, all we need to do is say stir copy, source, and then whatever the source is there, we can put in a string, and the same with the destination. You can also put variables in there as well if you wanted to copy those. But what we're doing here is the first parameter is where you're copying to. The second parameter is the string that you're copying. So source would have this is source inside of it after stir copy. Destination or dest would have this is destination inside of it after the stir copy call. The stir copy function does not check to see whether the source string actually fits in the target string. So what would happen if you had a big string? So in this previous example, what would happen if destination had 100 characters in it, and instead of having this is destination, it had 100 characters. This is destination, destination. You tried copying it into source that only had 50 characters. There would be a problem. The destination string would be larger than the source string that you're copying. Right? So if we tried to copy stir copy into source, instead of copying this is source, we put in this is source 5 times or 10 times or whatever it is, and it went over 50, there would be an error. And I'll demonstrate that. So a safer way to do copying strings is to use stern copy. You notice that N in between the stern copy. Stern copy takes a third argument, the maximum number of characters to copy. So here you actually specify how much you want to copy. So if you have a source of 40 and a destination of 12 sizes, you can first do an mset, which is just setting the size of the data inside a destination to null terminators. That way when you add something, it will automatically be there. Don't worry about that. The stir copy is going to copy hello, how are you doing to source. And it's not going to check if hello, how are you doing is larger than source. But if you do a stern copy and you copy in a destination, it's going to copy source and it's only going to copy the first 10 characters. So that third argument should correspond to the size of the destination. Dest. So let's go into code blocks and look at stir length and look at copying strings to see exactly how these work. So here we have our main. And to get the string length string is really easy. We're going to create our character array. We know how to create a character array. We don't want to specify the size, but we got to put the name first and then the brackets. And then we can initialize it with whatever we want. Say inside double quotes. Double quotes represent string literals. So I can just say, my name is Jason. The end result of this is S is going to be an array of size 1, 2, 3, 4, 5, 6, 17 characters. All of these characters plus the null terminator. The null terminator is the \0. You don't have to put that in there because it automatically gets added by the compiler. That's how we can initialize and create a string in a character array. Then to print it, all we have to do is say printf and say the length is. And then we put the %s as the format specifier to display a string. And then all we do is we say the name of the string. And to not get confused, let's just say my string. And we don't have to use the ampersand like we did previous examples. We can just say my string. If we compile and run this, we also may have to make sure we include the string header. When we compile and run this, you're going to see the length of the string. So the length is, and I didn't call the string length function, so you have to actually call the function if you want to display it, the length. So you just do something like that. You put the string inside stir length. And now when you run it, you'd actually see the length of the string. Got to make sure, okay. And I forgot a parentheses. And this is now complaining about, this has to not be a string, but an actual. So that's how I would display the string. If I want to display the length of the string, I do %d and call the function. Now when I run it, you'll notice that it actually prints out 16, which is the length. So it's a pretty easy function to use stir length. If you want to copy strings, you use stir compare. And you want to use stir and compare to actually specify the bytes. Right. So here if we have my name is Jason, and then we create another string, actually we'll just keep it that we won't even have to specify. And what we're going to do is we're going to say create another string called temp, and that's going to be equal to stir and compare. We're going to pass in what we want to copy to. So actually let's do this. Just create an empty character array, and we're going to just make it of size 50. And what we're going to do here is we're going to say stir and compare. Stir and copy, CPY. The first parameter is where we want to copy to. We're going to say temp. The second parameter is what we want to copy, which is my string. And then we don't want to pass in more than 50 bytes. So we can actually say size of temp to say we don't want to pass in more than 50 bytes. And you probably want to do -1 for the null terminator. And this way, that third parameter is really important because we're never going to have buffer overflows. You should always use stir and compare and not stir, or stir and copy and not stir copy. And then here we can just display our string to see if it was copied. We can say temp, change it to a %s. And when we build this, we should see not the length, we should see the string is. Something like that. And end it with a semicolon. There we go. Now we should compile, we do. So now we run it, we should just see our string that was copied in. Oops. And so we see my name is Jason. And that is stored inside of temp because we printed out temp. But always use string copy, don't use stir copy. That will make sure that you don't have buffer overflows. And the third parameter should always be the source, right? Not the, the destination. Not the source, the destination. It would be pointless to say copy this entire string because if this is smaller, you're going to have problems. So always say the size of this. And you see that you can use the size of operator to see how many bytes are inside of character. All right? Let's talk about some more functions. So we know how to get the length, we know how to copy strings. How about concatenating strings? The stircat function takes two strings as arguments, and it copies the second string at the end of the first. The second string is not altered, only the first. It will return the value of its first argument, the address of the first character of the string to which the second string is appended. So it returns something telling you where you actually appended it if you ever needed to use that. So here's an example. We create a character string of myString, and it just contains myString with a null terminator. We create a character string of input, which is 80, it's empty. We say enter a string to be concatenated. We read it in, and then we concatenate it. We print out the original string followed by the concatenated string, and then the input. So if after this, whatever you entered would be put at the end of my string. So if you entered Jason, it would be my space string Jason. That's what my string would be equal to. Because you do a stircat on it. Right, so the one thing we didn't do here was, here it is right here. First we print out the string and then we call stircat on it. Input is actually going to be equal to whatever was input, my string followed by whatever was input. We'll go through this example in a sec. Now just like stir copy, stircat also has a stir and end cat. So the combined version becomes the new first string. Oh, my slides keep getting messed up. I double check them and they still have, I got to become better at PowerPoint. Anyways, so just like string concatenation with the stir cat, there's a stern cat. Stircat has the same problem as stir copy. It can have a buffer overflow. It doesn't actually make sure that the second string will fit in the first array. So if you don't have enough space in that first array, you can run into buffer overflow problems. So what you want to use is stern cat. The second argument indicates the maximum number of characters to add. So for example, if you do a stern cat and two strings, bugs, and add-on, it's only going to add the first 13 characters of add-on to bugs. Depends which comes first. If add-on is less than 13, then it will only add till you see the null terminator. So in this example, we're creating two strings. This is the source, this is the destination. We're doing a stern cat. We're only copying 15 characters into destination at the end. So if whatever the size of destination will be size of destination plus 15. And then we print it out. So let's look at this in code blocks again. So here we are. Here's our example. And we're going to create two character strings array, one size 50, the other size 50. We're going to do two stir copies to set them to data. This is the source, this is the destination. And then on line 12, we do the stern cat. And destination is going to be what we concatenate to. So the source is going to be what we're going to concatenate. And we're only going to assign 15 characters. So if source was bigger than 15, we wouldn't copy all of them. So when we build this and run it, you're just going to see that it now says this is source followed by this is it's going to say this is destination followed by this is source. So it says this is destination, this is source. It concatenated that onto the end of destination. So you always want to use stern cat for concatenation so you don't have buffer overflows. Let's talk about stir compare, which I keep accidentally saying instead of stir copy. Stir compare. So for comparing strings, we have to also use a function. If you want to compare one string to another, you can't use double equals. That only checks for references, whether or not you have the same address. So what you need to use is stir compare. This is going to compare the string contents. It does not compare the arrays, so it can be used to compare strings stored in arrays of different sizes. It does not compare characters. You can use arguments such as apples and a in double quotes, but you cannot use character arguments such as a single character, a. This function does for strings what relational operators do for numbers. Right? So the compare function is going to return a value that tells you whether or not the string is equal, whether it's larger, or whether it's less than. If it's equal, it's going to return 0. If it's less than, it's going to return less than 0. If stir1 is less than stir2. And if stir2 is less than stir1, it's going to return greater than 0. And so what exactly does this mean? Well, let me provide you with an example of how this works. Let's put this into code blocks and run it. But here we're doing a bunch of stir compares, and we're going to tell you what the values are, whether they're less than or greater than, because it's not very clear. So let's take this and look at it in code blocks. Okay, so here's our example. And we're comparing a bunch of strings and then just displaying the results of stir compare, whether it's a 0, 1, or whatever. So if you compare two strings, A and A, they have to be in double quotes. And what you see here, what we're doing is we're printing out what we're calling. So we're delimiting the quotes. We're putting the backslash so that we actually print out a quote character, and it doesn't end the string. But if we compare A and A, this should return 0. Because 0 means strings are equal. If we compare A and B, stir compare should return less than, because A is less than B. BA, it should return a greater than 0. But let's go through this to make sure I don't make any mistakes, and we'll actually see it in the output. So when we run this, and this helps you remember what numbers are going to be returned. So when you compare A and A, you actually get 0. If you compare A and B, B is less than A, so it's a negative 1. Something less than 0. I might have said the opposite. See, even I still get them confused. Because A is greater than B. A is greater than B, negative 1. B is less than A, so you get something greater than 0, which is a 1. C is greater than A, so you get 1. Right? Just like when B was greater than A. And then you're comparing uppercase and lowercase. When you compare uppercase and lowercase, it does the inverse. Z is actually less than lowercase a. So capital is always less than lowercase. If you try to compare apples and apple, it's going to be 1 because apple is less than apples. And that's how the comparisons works. It's important to understand the 0, greater than 1, or less than 1. Again, less than 0 is going to say that the first string is less than the second string. And greater than 0 is going to say the first string is greater than the second string. This function is very easy to use. You don't have to worry about any kind of strn compare because it doesn't matter the size of the arrays that you're comparing. The stir compare function compares strings until it finds corresponding characters that differ. So it could be all the way to the end of one of the strings. Stir and compare function compares the strings until they differ or until it has compared a number of characters specified by the third argument. So in this case, you don't need to use stir and compare for buffer overflows. It exists, but you only would use it if you only want to compare a certain number of characters. It's used differently than the stir copy or the stern copy or the stern cat. The stern compare just says I only want to display so many characters. So it would be useful if you're only looking for a prefix. So if you wanted to search for strings that begin with astro, you could limit the search to the first 5 characters. And you would use stir and compare this way. So this example would actually, and you see that we say equals equals 0. You often see an if statement like this when you're using stir compare. You see stir compare inside of an if statement and the equals equals 0 to say that it's equal. So if stir and compare uses the first 5 characters, compares astro to the first 5 characters of astronomy, it's going to say that it found it. It's going to be equal to 0 and it's going to say found astronomy. If you do the same thing but comparing it to a different string called astounding, it's not going to find it. It's going to actually display. It's going to say that astounding is greater than astro, so it's going to display something greater than 0, which is a 1, and it's not going to display any data. So use stir compare when you're comparing strings for all the contents. Use string compare when you only want to compare a prefix to a string. Same type of syntax or string compare, just that third argument. Okay, so we talked a lot about some really important functions that we're going to use, mainly string length, string copy, string cat, and string compare. We're going to have a challenge where you have to utilize these functions. It will get you familiar with it, but you're going to become really familiar with this because you're going to end up using them over and over and over again. Thank you.